As our home planet faces unprecedented challenges, our eyes turn skyward for hope and survival. Welcome to Youniverse Revealed, where today we journey through the importance, limitations, advancements, and electrifying future of space travel. From the dawn of the space age with Sputnik and Apollo to the International Space Station orbiting overhead, humanity's quest beyond Earth has been relentless. Now, as we stand at the threshold of interplanetary habitation, we explore how the leaps in technology and the innate human spirit of exploration are paving the way for tomorrow's odysseys. Strap in as we propel through the latest in space exploration, from lunar outposts to Martian dreams, and how these celestial endeavors might just secure humanity's fate. Space is a vast unknown. It's hiding unending secrets and is filled with possibilities. Venturing into space presents the advantage of safeguarding our civilization from a potential planet-wide catastrophe. While Earth currently provides a hospitable environment, the necessity to depart from our planet will inevitably arise at some point. And perhaps out there in space we'll find new homes, resources, or even solutions to protect our beautiful home planet. The desire to explore space is not a recent development, though. Humanity has been venturing into the depths of space for decades, with a rich history of space travel. Humanity's journey into space has been marked by groundbreaking milestones. First was the launch of Sputnik, the first artificial satellite by the Soviet Union in 1957. Then in 1961, Yuri Gagarin orbited Earth. He was the first human in space. The United States Apollo 11 mission further extended our reach. It landed astronauts Neil Armstrong and Buzz Aldrin on the moon in 1969. Several more lunar explorations followed that feat. Human missions haven't ventured beyond Earth's orbit since, but over 500 people have been to space. They have contributed to our continuous presence on the International Space Station and expanded our knowledge of the cosmos. Since 1957, satellites orbiting Earth and robotic spacecraft traveling away from it have collected significant data about the Sun, Earth, other celestial bodies in our solar system, and the broader universe. These robotic spacecraft have achieved successful landings on the Moon, Venus, Mars, Titan, a comet, and 4 asteroids. They have also visited all the major planets. They have flown past objects in the Kuiper Belt and approached the cores of comets. This includes Halley's Comet, which travels within the inner solar system. Space holds a wealth of precious materials. Recent missions like Hayabusa 2 and OSIRIS-REx have also retrieved samples from comets and asteroids. As of 2024, the farthest human-made probe has been NASA's Voyager 1 mission. It has traveled 14.67 billion miles from Earth, while the nearest star is approximately 4.24 light-years away. Analyzing the data obtained from space has helped scientists deepen their understanding of the origin and development of galaxies, stars, planets, and other cosmological phenomena. However, this understanding remains incomplete, as there is much waiting to be discovered in the universe. Space is full of secrets waiting to be uncovered, and exciting missions are on the way to do just that. One key mission is the Mars Sample Return, where NASA and the European Space Agency team up to grab bits of Mars and bring them back to Earth. This could help us learn a lot about Mars, like if it ever had the conditions for life. Another cool mission is JAXA's MMX, which plans to visit Mars's moons Phobos and Deimos. It aims to scoop up some of their dirt and return it to Earth for study. But there's more. NASA's Artemis program is gearing up to send astronauts back to the moon, setting the stage for people to live and work there. And then there's the Dragonfly mission, which is like a giant drone heading to Titan, Saturn's largest moon. It's going to fly around Titan, studying its atmosphere and surface to see if it could support life. Each of these missions uses amazing technology to explore space, aiming to answer big questions about our solar system and beyond. They're like interstellar detectives uncovering clues that could tell us more about our place in the universe. Space exploration is not our evolutionary trait, but it has driven the development of useful technologies. They benefit the economy and enhance life on Earth. GPS, accurate weather prediction, solar cells, global communication, and UV filters in sunglasses and cameras owe their existence to space programs. But advancing towards the moon, Mars, and beyond demands far more efficient technologies than just GPS and weather prediction for safe travel. These technologies include propulsion and fluid systems. They also include thermal management, navigation, and landing systems. They would be used for supplies, equipment, and explorers on diverse surfaces. And we surely can't forget the rapidly emerging use of artificial intelligence. Numerous projects are currently leveraging AI to advance space exploration and spacecraft development. Space agencies globally seek to use advanced automated systems on space missions. Autonomy will be key to the future of solar system exploration. This is especially true when robots operate without constant human communication. Beyond that, researchers are advancing science instruments, modeling, and simulation technology. These are state-of-the-art tools. They gather information on planetary geology, atmosphere, and the environment. These technologies include remote sensing, mapping, and observation tools. They also include the analysis of light from the universe and the search for signs of life. NASA is actively developing high-end and reliable space communication systems. They are essential for every mission. These systems facilitate the transmission and reception of spacecraft commands, novel images, and scientific data. They do this through NASA's massive antennas on Earth. Whether it's the Voyager mission venturing beyond our solar system or astronauts aboard the International Space Station, space communications serve as the vital link to our home planet. Scientists are working on the first fixed-wing plane along with walking robots for the Mars mission. There is a possibility that these robots might populate the red planet in the future. But just robots roaming on alien planets is not enough. The future of space exploration demands both telescopic and physical exploration using robotic spacecraft as well as human missions. NASA, along with 26 other space agencies, has actively participated in the International Space Exploration Coordination Group. The goal is to develop and enhance a comprehensive long-term strategy for human space exploration. There are plans for crewed missions to the Moon and Mars. They aim to establish scientific colonies for future settlements. But why is it needed? Why risk human life? The fact is that our lives are already at risk. With over 8 billion humans on Earth, our species faces a risk of extinction if something catastrophic happens. Colonizing other solar system bodies or constructing orbiting habitats can serve as a backup to ensure humanity's survival in case of events such as asteroid impacts. NASA's DART mission is working on asteroid deflection technology. It could prevent dangerous asteroids from approaching Earth, but it won't keep us safe for long. Some wealthy space entrepreneurs predict imminent Mars colonization, which remains a long-term goal. This will require significant technological advancements to sustain human life away from Earth. Maybe future humans will be Martians who will never set foot on Earth. But that isn't happening anytime soon. This is when the Moon comes into the picture. The Moon is being considered for colonization due to its proximity and lower escape velocity. Permanently shadowed craters near the poles contain abundant ice, crucial for water needs. Additionally, precious metals like gold, silver, and possibly platinum are concentrated there. Interest in establishing a moon base has grown in the 21st century as an intermediary step toward Mars colonization. It offers proposals like the Moon Village. These proposals are for research, mining, trade, and permanent habitation facilities. So the Moon will serve as a testbed for the larger mission of Mars colonization. Exploration may extend to other planets as well. Settlements on the Moon and Mars could involve mining, especially in the asteroid belt. Human space exploration is thus crucial for our survival as a species. But sending humans into space also brings with it a whole new set of challenges. Transitioning gravity affects orientation, coordination, and balance. Astronauts in long-term space missions could experience multiple health issues. These could include bone density decline, cardiovascular deterioration, and muscle strength loss. They could also experience kidney stones, vision problems, and exposure to harsh radiation. Harmful radiation can also damage the central nervous system, causing behavioral changes. Crewed missions might also face issues with food storage and resupply. NASA estimates that a 3-year Mars mission would require about 24,000 pounds of food. Most of it would be pre-cooked and dehydrated meals weighing around 1.5 pounds or 0.68 kilograms per portion. Despite all these challenges, we must find a way to continue space exploration. NASA's current research at the ISS covers biomedical studies, material science, technology advancement, and methods to further space exploration. Anti- and microgravity conditions enable medical research that could lead to breakthroughs in disease treatment and life extension. Space exploration could save your life someday. Numerous private companies are working to enhance space travel efficiency at lower cost. They also aim to help with space exploration and colonization. SpaceX is a prominent leader in this endeavor. They introduced the reusable Falcon 9 rocket for this very purpose. On the other hand, NASA is actively enhancing our space access and travel capabilities. They are working to land more mass at various solar system locations. It aims to set up habitats in deep space and on planets. It also aims to build next-gen air vehicles and improve tools for deep scientific research. There are numerous practical reasons for space exploration. One of the primary motivations is the innate human desire to explore the unknown. The drive has shaped humanity's evolution, leading to a planet-spanning civilization. Space exploration leads to new scientific findings and technological breakthroughs. It's also an opportunity for global collaboration toward a common objective. It's an opportunity to transcend national, racial, and political boundaries. Failure to embrace this collective endeavor diminishes our essence as humans.